Ever wondered how massive platforms like Amazon or Uber generate unique IDs for millions of orders or users every second without even breaking a sweat? Think about it. What happens when two servers try to generate IDs at the exact same time? How do you ensure that those IDs are unique and are always increasing? Why can't we use something simple like auto increment IDs? What's wrong with using UUIDs for everything? In distributed systems, generating unique ID is not as simple as it sounds. With multiple servers running across different regions, ensuring that IDs don't collide, stay unique, and are sequential requires careful design. In this video, we will design a unique ID generator for distributed systems. We will understand the problems and try to solve it with our system design. So let's look at the problem statement first. This video is part of my system design playlist where I will be discussing high level designs of some of the most classic system design problems. So don't forget to subscribe to my channel. And before thinking of the solution to the problem, let's first understand the problem statement and the scope in which we want to design. So one important point here is the ID should be increasing in order. Like an ID that is generated at a later time should be numerically greater than the one that was generated previously. Now the ID should not necessarily increase by 1, but it should be in an increasing order. The second is I just want numeric IDs for my ID generator. It means ID should be a number. It should use digits between 0 to 9 to generate the IDs. The ID should not use more than 64 bits to generate the ID. And regarding scale of the system, I want to generate 10,000 IDs per second. And needless to say, all the IDs should be unique. With these points keeping in mind, let's start designing our system. Broadly speaking, there are three main options by which we can generate unique IDs. The first is that we something called multi-master replication. The second is we must have heard about it, UUID. It stands for Universally Unique Identifier. And the third is Snowflake Approach. This is actually Twitter's approach. So let's look at these one by one. So multi-master replication, it makes use of the database's auto increment feature. So all the database which are relational have something called auto increment. Any new data that is added to the database, the primary key is automatically incremented by 1. So this will use this auto increment feature with a small tweak. The tweak is my ID generator. Let's say this is my ID generator. It will have various relational databases, like this is one database, this is second, and this is third. Now ideally each database will increment the ID by 1. Now instead of increasing the ID by 1, each database will increase the ID by I plus 3. Let's see how this works. So let's assume this database has a value of 1 and this has an initial value of, let's say, 2, and this has an initial value of 3. The next ID that is generated here is I plus 3, that is 4, and the next ID after this will be generated as 7. Similarly here the next ID will be 5 and the next will be 8. Similarly here the next ID will be 6 and then 9. Now finally whatever ID this generates all will be unique, and since we are using multiple databases together to generate IDs, we can leverage the distributed system part of ID generation since these are distributed in nature. So you might think that okay, this works fine, it generates unique IDs and it is distributed in nature, but it has some major drawbacks. One major drawback is this system is very difficult to scale when we want to use multiple data centers across the globe. So I will write it down. It is difficult to scale. Now what happens when you want to add or remove, basically change the number of MySQL instances? This value I plus k, this k will change. So k here is basically the number of relational databases. If you want to add a new box, you have to go to each of the database and change the value of k. So change the number of SQL servers is difficult and it is not scalable also. Boxes is difficult. And the most important point is the IDs don't increase with time. For example, if the ID is requested from the first box, it gives 1, the next ID it gives is 4. After that, if the input ID is from the second box, the next ID is 2. IDs don't go up with time. So these are the disadvantages of multi-master replication. Obviously, if you don't have these restrictions, you can definitely use this approach. Now let's look at the second approach, that is UUIDs. As the name suggests, UUID is Universal Unique Identifier. So some characteristics of UUID is it is 128-bit long alphanumeric string. What it means is the generated identifier contains both alphabets and number. There are libraries and different programming languages or packages to generate UUIDs. Now, you might be thinking that if there are libraries that generate UUIDs, like why can't there be collision? Like when you generate random numbers, you usually get collision. The thing with UUIDs is there's a very less chance that two generated random UUIDs will be exactly same. To give you a little bit of perspective of how it is, Wikipedia says that if your system generates 1 billion UUIDs every second and it continues to do so for approximately 100 years, the probability that the newly generated UUID will be 50%. Basically, the probability of creating a single duplicate after generating 1 billion IDs for 100 years is 50%. So now you can imagine how unique these UUIDs are. So for all practical purposes, we can say that it is safe to use UUIDs to ensure uniqueness among the IDs. There are some benefits of using UUIDs that even in a distributed system, you don't need coordination among the servers or ID generators. And as a result, scalability is easy to achieve. And now looking at some of the cons for this, we wanted a 64-bit long ID, but it generates a 128-bit ID, which does not suit our system. You might think, okay, we can choose the first 64 bits of the uniquely generated ID, but with that, you can't guarantee that all the IDs will be unique. So one major con is it does not satisfy our length of the ID. The second is we only wanted numbers in our ID, but this is an alphanumeric string. So in this, IDs are not numeric. And the third important thing is IDs don't increase with time. Now this is about UUIDs and why we can't use UUID in our system because it doesn't satisfy the constraints. Now obviously if you didn't have these constraints in place, you can use UUID in your system, and it is actually used in many places in the system since it is like easy to generate and you don't need coordination. Now let's look at the next approach, that is called Snowflake approach. Now we saw two ID generating approaches, but none of them meets our requirement. Let's look at the Snowflake approach. This approach was actually used by Twitter and they called it Snowflake approach. Let's look at how this works. Twitter, instead of directly generating IDs, it used something called divide and conquer. We want to generate 62-bit IDs. So as per this approach, we need to divide our bit space. By bit space, I mean, so out of the 62 bits, what Twitter did is it used one bit and named it signed. For the next 41 bits, we will fill this with timestamp. For the next 5 bits, this will specify the data center ID, and the next 5 bits will be machine ID, and the next 12 bits will be a sequence number or a random number. So this signed 1 bit, we will reserve it basically for future users to indicate if it is a signed number or an unsigned number. Since these are bits, they can have values 0 or 1. Now coming to timestamp, let's do some maths here. Now for timestamp, Twitter actually used a Twitter's default epoch, and this is actually in milliseconds. So Twitter took a timestamp. So let's assume like this is our custom epoch time, and then we have something called current time. Now this will give us some time in milliseconds, and we know that this time can be represented in 41 bits. So this time stamp will be entered here. And then we have something called data center ID. If we are using 5 bits, we can have a max of 32 data centers. Now, if we know that we will have more than 32 data centers, we can increase the number of bits here. each of the data center will have a unique number associated with it. We will convert it into bits and store it here. The next comes machine ID, which we have also allocated 5 bits. The maximum number of machines a data center has can go up till 32. This is an assumption, and if we know that each data center may have more than 32 machines, we can increase the number of allotted bits to this machine ID component. For example, the timestamp is something like 01101101011. Data center ID is something like 01100. Machine ID is 00001. And the last part is sequence. Now, in theory, a machine can generate 4096 number of numbers in 1 millisecond. Now, that is exactly why we have specified 12 bits here, because using 12 bits, you can generate 4096 combinations. You can have a random sequence here that the machine generates. In theory, this field can always be 0 unless we are generating more than one ID per millisecond, and this by default we will keep 0. So this is the binary representation of our ID, our 64-bit ID that we wanted to generate. Now this approach takes care of all the things. One is that the ID is numeric. The second is, since we are using timestamp at a higher bit, so any new ID that is generated later is numerically greater than the ID. The third is we are generating an ID that has a length of 64 bits. You can actually tweak the number of bits allotted to each sequence to suit your use case. This is a very good approach for ID generation across distributed systems. And that's a wrap. There are some more points which I wanted to discuss. The one is clock synchronization. Now, since the Snowflake approach makes use of timestamp, we need the clock to be synchronized across all the data centers across the globe. Now, this is not a very easy thing to achieve, especially for distributed systems. So for this, we can use something called NTP, which is Network Time Protocol. Now, we won't go into detail of this as it is a whole other discussion, but to give an idea, it syncs the clock till milliseconds. So this is something I wanted to discuss. I hope you like this video. If you like this video, don't forget to subscribe to the channel Code with GT and share this with your friends. See you in my next video. Till then, happy coding. Bye bye.